Okay, sorry, got cut off there. So let's, so again, on that one, making sure that this I squared, you're converting to -1. So if you were to do this one over here, again, we're drawing, and we're going to have 2, and we have positive 3i. We have -2 and -2i. Positive 2, -4, -2, positive 3i, -6i. This is going to be -4i, -6, and then it's going to be I squared. You don't need to put that in parentheses. I don't know why I did that. So if we put our real parts first, it's going to be -4, and then this right here is -6 times -1, because I squared is -1. So this is going to become +6, and then our imaginary parts, -4i, -6i. If we combine together, this is going to give us 2, and this is going to give us -10i. All right, so that's our multiplication. Flip on to the back. If you're going to divide, when you divide, you're multiplying by the conjugate. So the conjugate is the opposite sign for the imaginary part. So this is going to be 1 plus 5i over -6 minus 2i. So you keep the original, and then to divide, you're going to multiply the numerator and the denominator by the conjugate. So it's going to look like that. So again, this was negative, so we made it positive. And then it just becomes 2 big multiplication problems. So it's going to be this times this. So over here, if we did it right here, we'd have 1 and 5i, and we'd have -6 and 2i, like that. And so if you multiplied, you'd have -6, -30i, 2i, and then this is going to be 10i squared. If you were to put all this together, then you would end up getting, as your new numerator, so if we put it again as our new numerator, we're going to end up getting -6, and this is going to be -10 because it's going to be 10 times -1. So -6 and -10, that's going to be -16. And then if we put these together, this is going to be plus 28i. Then we're going to go ahead, we're going to do the same with the denominators. So we're going to multiply across. It's going to be -6 and -2i. It's going to be -6 and positive 2i. So this is going to give us 36, positive 12i. This is going to give us -12i. These are always going to cancel, and this is going to give us -4i squared. So that's going to give us 36, and then this is -4 times -1. Okay, so -4 times -1, that's going to be positive 4. So if we add those together, we're going to get 40. And then you're just going to go ahead and you're going to break down your fractions. So if you can break down your fractions, it's going to be -16 over 40. See if that can reduce, and it does, to -2 over 5. So this is going to be -2 over 5. That's going to be your real part. And then if you do 28 over 40, that's going to also reduce to 7 over 10. So it's going to be plus 7 over 10i. That would be your final answer. Okay, so then you do the same one for the next one. So if you were to multiply, it would be 2 plus 3i over -2 minus 2i. So we're going to multiply by the conjugate. So -2 plus 2i, -2 plus 2i, and then we're going to multiply out. So if you start to multiply out, okay, again, we're going to come over here. And if we draw what we have, it's going to be 2 and positive 3i. It's going to be -2 and 2i. This is going to give us -4, -6i, positive 4i, and then this is going to give us 6i squared. Okay, so what that's going to give us is we're going to have negative 4, and then this is going to be negative 6 because it's 6 times negative 1. That's going to give us negative 10. These are going to get added up. 4 and negative 6 is going to be negative 2i, and then we're going to multiply our denominators. So if we multiply our denominators, negative 2, negative 2i, negative 2, positive 2i. This is going to give us positive 4, 4i, negative 4i, and then this is going to give us negative 4i squared. These are always going to cancel in your denominator. All right, so those cancel in your denominator. And here you have negative 4 times another negative 1 because I squared is negative 1. Negative 4, negative 1, that's going to give us positive 4. 4 plus 4 is going to give us 8. All right, so that gives us 8 right there. So then if we start to break them down separately. Negative 10 over 8, we can divide both of those by 2, so it's going to be negative 5 over 4. Negative 2 over 8 is going to give us minus 1/4 I, or you could say I over 4. Either way would have been correct on that one. Okay, so division's probably the most tedious of all the operations. Next is plot complex numbers. So remember, your real axis is always your x-axis, and your imaginary is always your y. So this is telling you positive 4 for your real part, so to the 4 to the right, negative 5 for your imaginary part. So positive 4, negative 5, that point would be right here. Here, this is telling you negative 2 for your real part, so negative 2, and then positive 1 for your imaginary part. So that would be right here. Okay, so that's plotting. Your modulus, so remember complex numbers are written a plus bi, and your modulus, so the modulus, which remember is written like the absolute value is what it looks like, is equal to the square root of a squared plus b squared. So not worried about the imaginary parts, just looking at the real parts. So this would be the square root of negative 6 squared plus negative 2 squared. This would be equal to 36 plus 4. So the square root of 40, you should be able to break that up. So you break it up into perfect squares. So the only square that divides into it is 4, and it's going to be 4 and 10. So this is 2 root 10. So you take the square root when you pull it out, and then you're here. So if I wanted to find the modulus of this, it would be the square root of 2 squared plus 3 squared, which is going to give us the square root of 4 plus 9, which is the square root of 13. That cannot be broken down anymore. 13 is a prime number. So these would be your moduluses. Always positive numbers because it's a length. Answer conceptual questions related to the modulus of a complex number. So just understanding that the modulus is the distance from 0, or from the origin, distance from the origin. So like if we were to go back up to these, you could connect this line back, and the length of that line would be your modulus. The length of a line straight from the origin to here, which that's not a straight line, but if it was, that would be your modulus. Okay, last page, here we go. So last page, find the distance between two complex numbers. So the distance is going to just be the distance formula. Okay, so the distance formula is x1 minus x2 squared, and then y1 minus y2 squared. Pick which one you want to be your x's, pick which one you want to be your y's. So if I was going to write this one all out, I would say 1 minus negative 6 is going to be 1 plus 6 squared plus 5 minus negative 2 is going to be 5 plus 2 squared. Then just multiplying it out and seeing if you can break it down. So here, this is going to end up being 7 squared plus 7 squared, which is going to be 49 plus 49, which is going to end up giving you the square root of 98. And then again, see if you can break down that number. So is 98 divisible by 4? No. Is 98 divisible by 9? No. Is 98 divisible by 16? No. So if you can't break it down any further, this would just be the distance between those. All right, same thing happens here. So this is going to be 2 minus negative 2 is going to be 2 plus 2 squared, plus 3 minus negative 2 is going to be 3 plus 2 squared, so it's going to look like that. This is going to equal 4 squared plus 5 squared, which is going to be the square root of 16 plus 25. If you add those two numbers together, you get the square root of 41. Again, in this case, that does not get broken down any further, so it's just going to stay as is. Next thing, given the multiple complex numbers, determine which complex number is closest to the origin. All right, so that's just going to be comparing the modulus. Whichever one has a shorter modulus, that's going to be the one that is closer to the origin. So if I were to do this one, I have 1 squared plus 5 squared. This is going to be equal to the square root of 26. No need to break these down because you're just comparing. So then if I do the second one, I have the square root of negative 6 squared plus negative 2 squared. That's equal to the square root of 36 plus 4, so the square root of 40. Obviously, this one is closer because it has a shorter modulus. Same thing over here. So this is going to be 2 squared plus 3 squared. This is going to be the square root of 13 because 9 plus 4. Over here, I have the square root of negative 2 squared plus negative 2 squared. That's 4 plus 4. That's going to be the square root of 8. All right, well, obviously this one's shorter. So this is going to be my shorter one of the two. All right, obviously this one was shorter. Okay, last couple things real quick. So determine the quadratic function when you're given the roots. Okay, this is a weird process. So this is one of those things. Have it memorized for tomorrow, and then if you don't remember how to do it after that, we can go over it for the midterm. So this is the same thing as 1 plus or minus 3i. We can agree to that, right? 1 plus 3i, 1 minus 3i, 1 plus or minus 3i. So if we set that equal to x, because this is a solution, our goal is to now create a quadratic equation, all right? So that means in your quadratic equations, you do not have i's. So you're thinking, how can I get rid of the I? Well, the way that you can get rid of the I is to square the I, but at the same time, you cannot change the value of this thing. So if you square one side, you got to square the other side. So let's move this over here, and we're going to have x minus 1 is equal to plus or minus 3i. Okay, so if I square this side and I square this side, x minus 1 squared, do the box method, you're going to get that it's x squared minus 2x plus 1 is equal to, if I square something, that plus minus goes away because whether it's negative 3i squared or positive 3i squared, the squared is going to make that negative positive go away. So this is 3 squared, which is 9, and I squared. Well, 9i squared, this is just equal to negative 9. Okay, so we have x squared minus 2x plus 1 is equal to negative 9. Well, if I want to write it as an equation, the last thing I need to do is I'm going to add 9, x squared minus 2x plus 10 is equal to 0. This would be your equation. Weird process. Again, if you need help before the test, just let me know. Okay. Last thing, answer conceptual questions about complex numbers, all right? So just understanding complex numbers represent non-real roots. Okay, know that I is equal to the square root of negative 1. Know that I squared is equal to negative 1. I to the third power is equal to negative square root of negative 1. And I to the fourth power is equal to just 1. So if it asks you a question like, what is I to the 13th power? Think about how many I to the fourth you can pull out, because those are just 1. So you can rewrite this as I to the fourth, I to the fourth, I to the fourth times I, right? So all of this is just 1 times 1 times 1. So that doesn't mean anything. So this is the same thing as just I. It's a circular number. So just if it asks you something like that. And then the last thing, find zeros of quadratic equations that are non-real. You would try to factor this. If it doesn't factor, you're going to use quadratic formula. So negative b is going to be positive 2 because it's negative negative 2. Plus or minus the square root of b squared, all right, is going to be negative 2 squared minus 4 times your a value times your c value. All over 2 times negative 2. All right, if you break down what you have inside 2 plus or minus, all right, and we know this is all over negative 4, okay? If we break down everything that we have inside the parentheses, I'm just going to use the calculator for the sake of time. We're going to have 4 and then minus 80. I guess not even use the calculator. So we're going to have the square root of negative 76. Okay, that's what you get when you break down inside there. So now we need to break down this negative 76. So if you think 76, is that divisible by a perfect square? So is 76 divisible by 4? Yes, you get 19. So it's 4 and 19. So we're going to rewrite this as 2 plus or minus. And then when I take this 4 out, it's going to become 2. When I take this negative out, it's going to become I. That's how you get your complex part. The 19 is going to stay inside. And this is all over negative 4. Now, you can leave it this way, but if you want the real part and the imaginary part, you need to go one step further and say negative 1/2, because 2 over negative 4, plus or minus. The negative doesn't really matter here just because it's already plus or minus, so it doesn't really matter. So this is just going to be I root 19 over 2, because these reduce, these reduce. That would be your final answer. All right, hope that all helps.